Hello everyone. In this video, we will see about blinking LED using Tinkercad as well blinking LED in Arduino IDE application. Here, in order to do blinking LED activity using Tinkercad, first thing we need an account in Tinkercad. Personal account, you can able to log in. As per the previous videos, I have shown how to create. Now let us proceed the blinking LED activity using Arduino UNO controller. So in order to make the LED to blink in a continuous way, we require basic components are a resistor and an LED. The required components which are there on the right side of the panel has to be placed on the white screen of the dashboard. Here we can able to place the necessary components. Here we can see the Arduino UNO is placed and a resistor and LED is also placed. Here the LED shows two terminals. One is anode, the other terminal is cathode. Anode is a long terminal shown and cathode is a short terminal. And the resistor has a no representation of polarity. We can use any way. So let us have these two components is more than enough to represent the blink LED activity. We can able to change the color of the LED by selecting the component of the LED. We can able to select any of the color whichever is preferred. So currently I have selected the red LED, red color as an LED. And by you can able to change the resistance value is also possible. So currently by default value it shows as a 1 kilo ohms is the units. We can able to change whichever the value we want. We can change the resistance value by typing the necessary number here. So I am not changing any resistor value as well the LED color. So placing as it is. And in order to type the code that you need to control the LED. So that is the activity. So the controller can able to control the LED based on the instructions given by the user. So we are the users has to give instructions to the controller such that LED has to be blink continuously without any disturbance. So for that, on the top right side, you need to click on the code button. Here you can see two types of an options. One is blocks plus text and text. Currently, let us see go with only text format. So if we have any notification, go with continue. Texting representation, only text. As in the previous video shown that this Arduino IDE program goes with two functions. One is void setup, the other one is void loop. Void setup is used for the representation of the pin declarations as well variable declarations. This will be executable only once. Void loop is the main function, that is instructable function where the instructions is been writing inside this loop function. So currently in Tinkercad, this program will be available as a default program. So let us go with change. Some changes will be applied to this program in order to get further blinking activity of the LED which is being placed on the screen. So for that, let us go with the program. So here you can see the word that is a pin mode is a predefined word. It is not a user defined word. So, and pin mode is representing that the pin of the connectivity of the LED to which pin you have been connected. So currently I am not connected to any of the pin. So we can able to choose any of the pin as pin from representing of the Arduino UNO. You can see the digital pins has been representing from 0 to 13. So there were around 14 digital pins are available And similarly, there were around 6 analog pins are also available. Here in this experiment activity, we can see that LED is a actuator. LED is a actuator. So it is a output device and it will act as a digital component. So two activities can be, two modes can be taken up in LED. One is on, another one is off. So where I can able to compare this on and off modes to a binary data, that is 0 and 1. So that is why I will consider that LED is a digital component. So considering that, I am going to write the code that LED is being connected to any of the one pin from 0 to 13. So let us say it is being connected to pin number 4. That is my choice. You can choose any of your choice from 0 to 13. So as my option is being chosen with 4 and I have been representing that the pin number 4 is connected to LED and that device should act as a output device. LED is a actuator, whereas sensor is input devices, actuators are output devices. So LED is going to be emit the light. It is an output. So pin number 4 is being connected to LED and it is being represented with the output. And next loop, we are going to go with the function representation of the loop executing infinite number of terms. So here digital write. So as mentioned earlier, LED is a digital component. So the first, this is a single predefined word that is a digital write. So getting an output is a writing, reading input is a reading. So getting information from the external environment through the sensors, we are going to write the word called read. In order to achieve an output, you need to go for write. So, and the type of component is a digital. So you need to represent the write, a keyword predefined word is a digital write. So you need to make the LED to be on condition. As the pin has been connected to number 4, you need to go for changing the representation to pin number 4. And as in digital circuits, we have two conditions of making on and off conditions of LED, that is a logic high and logic low. So logic high representing that LED should be on, and another way logic low representing that LED should be off condition. So the 4-letter word high represents that LED is on condition. So once the LED is on, this line represents that LED is on. Once it is on, then it is been executable for the another line, that is a delay, that how much time the LED should on. So here the code is default shows it is 1,000. So delay is a predefined word representing that it has to be hold on time for the LED to be in on condition. So the delay time here mentioned is 1,000. So default value, whichever the mentioned inside the delay is representing with the scaling factor of milliseconds. So 1 milli is 10 power minus 3. If it is multiplied with 1,000, then it represents that the LED is on condition for 1 second. So let us change this value to maybe 4 seconds. And once again, once the on condition is stabilized, then you need to go for the off condition to get the blink activity. So another same line has been repeating, that digital write, and you have to represent the pin number, the LED number 4, and we have to make the LED should be off using the command called low. Now I will go for the next line, that is holding for the off condition of 1,000. So here 1,000 is a 1 second. So here it is been 4,000. Now the number of wait is millisecond is a 4,000 milliseconds. By default it is called 4 seconds. Once the program is completed, click the button of the code. So the right side of the panel will goes out. Now let us go with the connectivity of the components. So in the program, it is shown that number 4 is the connectivity parameter. So in order to protect your LED from the major current that is been coming out from the controller, the resistor has been used. There is no other option. I mean, there is no other another reason for this. That is adding of resistance for this blinking activity is the only reason is in order to protect the LED from the high current flow. So where it can able to oppose the flow of current. So here resistor has a no terminal representation. So you can use any of the terminal. It has to be connected to the pin number 4. So now I have been connecting the pin number 4 to first resistor 1 terminal, and resistor other terminal is being connected to anode of the LED. Once it is being connected, cathode of the LED is being connected to the ground. Once it is properly connected, then you can able to verify that connections once and twice without any mistakes. Once it is been completed, then you have to click for the start simulation. On the top right side corner, you have an option called start simulation. Once you click this option, then you can able to see the initialization and the simulation time you can able to see on screen. For 4 seconds it is off, then for the next 1 second is off, another 4 seconds is on. 1 second is off, 4 seconds is off. So this is a blink activity using Tinkercad. Now let us see the same blinking activity in Arduino IDE. Here on screen, you can see the blink LED program has been entered with 2 loop functions. One is void setup, other one is a void loop. So under void loop, the pin mode has been entered. Here you can see, rather than in Tinkercad, we can able to see the color representation. The predefined words are represented with the orange colored, and void is represented with the blue color. So pin mode, setup, digital write, delay, all these are predefined words. Once we place the cursor on top of the respective keywords, it shows that what it is. And there is a pin mode. Pin mode represents what it is. Void represents what it is. Digital write is represents what it is. What should be written inside the parenthesis of the digital write, what should be written in the parenthesis of the delay. Everything will be mentioned in the newer versions of the Arduino IDE application. So the same code has been entered here. Once the code has been entered, you need to save the program in your system. Once it is done, you have to go for the verification of the code. Just by clicking on top left side of the corner on the screen, you can see verify button. Click this button. Then at the bottom right, you can see this compile is been going on. Once it is done, it shows a done compiling, and it shows the global variables are 9% of dynamic, leaving 2000 for local variables, maximum size. So whatever the information that belongs to the code which is there in the on screen will be representing after compilation. Once it is been done, our work is to go for uploading the code. In order to upload the code, 2 things has to be remembered. One is the type of board that is being connected to the system is very important. So here you can see on go for that you need to go to the tools and select the board, and Arduino AVR boards, select Arduino UNO. Once it is selected, and you can see here with representing the type of board has been connected. And next thing is you need to select the port. So for that, currently I have been opened a device manager. In the port sections you can see. So let us, currently I have connected the Arduino UNO. So, and it is showing that USB port as a COM6. So for that, I need to go for the tools, and once again selecting the port as a COM6. Once it is selected and it is shows that symbol has been that the controller has been connected successfully to the system. Once it is been connected and your board has been selected, if you place the cursor onto this and it shows that your Arduino UNO is connected to communication port number 6. Once it is completely successfully set up, then you can go for uploading the program. For that, click on the right arrow button, that is the upload button. Then it go for the compiling, checking, and done compiling. And compiling is done, then uploading also will take place. And it shows that done uploading. If all the connections were made accordingly, which is being shown here in the Tinkercad, the similar kind of connections we need to establish in a physical mode. Here I have taken Here I have taken one Arduino board, one resistor and one LED which is being connected to the pin number 4. You can see the blink activity in the physical mode, that LED blue color light has been connected to the pin number 4. So where it is been blinking for the 4 seconds on condition and 1 second is off condition. So this is a blinking activity using Arduino UNO with the help of an application called Arduino IDE software. Thank you.